hexadecimal to binary conversions, base 16 to base 2. So starting off, we're going to start with our first question, which is 2f. Just ignore this on the right as this is just the key. What we're going to do is we're going to start off by splitting these two values and understanding what they each are. So first we're going to write 2 equals, and then we're going to write f equals to understand each value. And this on the right, which I've written here, is actually just a key for hexadecimal. So ignore this unless we need to use it. So the first thing we're going to do is we're going to split these into 4 bits. So we know, so let's just write, for example, 0, 0, 0 and f 0, 0, 0, 0. So 2, we know, according to this key, is just 2. So to convert from binary to denary, which number has to be a 1 on this 4-bit line for this to be 2? If obviously this one is 1, a 1 value, and this is the 2 value, and this is 4, and this is 8, and so on, we know that the only difference there needs to be with this code is that the 2 value will be a 1 instead of a 0. So just to write it again in a clearer way, it will be 0, 0, 1, 0. Then for the f, just to do the same thing, I'm going to write 1, 2, 4, and 8 under. And then f, which we know, according to this key, equals 15. So just write 15. What out of these numbers needs to be added to get to 15? Let's just do it. 8 plus 4 is 12. 12 plus 2 is 14. And 1 plus 14 is 15. So we know that all these values need to be a 1. So just to make it clearer, we're going to write on top 1, 1, 1. So, sorry, 1, 1, 1, 1, 1. Cool. Now, just so that it's clearer for us, we're going to write it down once again, just so that we can see it in a more clear way. We know that 2 is equal to 0, 0, 1, 0, and f is equal to 1, 1, 1, 1. Now, all we simply do is just put these two binary numbers together, and then we will get, let's write it over here, 0, 0, 1, 0, which is obviously the 2, and then the f, which is 4 1s, 1, 1, 1, 1, which gives us the value of 2f being 0, 0, 1, 0, 1, 1, 1, 1. Now, moving on to this second number, 9a3. So this one, once again, we're going to split it into bits to find out each value. So 9a3. So obviously, according to this, 9 is just a 9. According to the code, 9 equals 9. A equals 10. So we're just going to write a equals 10. And then the 3, obviously, according to the key and what we know, numbers from 1 to 9 are just the same numbers. 3 equals 3. Now, what we're going to do is we're going to split this into bits just to understand it once again. And numbers that make up 9, again, just to make it easier, 1, 2, 4, and 8. Numbers that make up 9 are obviously 8 and 1. So we just put zeros here and cross these zeros out. Now we know 9 is 1, 0, 0, 1. Now, the number 10. Again, we're going to write 0, 0, 0, 0. And 1, 2, 4, 8. Numbers that make up 10 are 1 and 1. So it'll be 1, 0, 1, 0. So obviously, if you add and cross this one out, obviously, when you add 8 and 2, it gives you 10. Now, moving on to the number 3. Once again, we write 0, 0, 0, 0, and numbers 1, 2, 4, and 800. Now we know to make up 3, you need to add 2 and 1. So we're going to have the binary number 0, 0, 1, 1, and cross this out. Now simply, we're just going to put this all in line, the same way that we did with the previous one, starting from the first value. So 1, 0, 0, 1. Obviously, we've got that one now. Moving on to the second one. 1, 0, 1, 0. Cross that out. Moving on to the third one. 0, 0, 1, 1. Now we know that 9a3 hexadecimal base 16 is equivalent to binary value base 2 of 1001101100011. Thank you guys for watching.